Okay, so in this video we're going to spend probably just a few minutes going over and finishing what we had just started in the previous video, which is we have a mass on a 1.23 meter long string being swung around in a circle that has a radius of ½ a meter, and we sort of figured out that top angle is 24 degrees. We know that it was a 500 gram mass that had an acceleration due to gravity of 9.81 meters per second squared. So we found force gravity, and we ended up solving a right triangle, and we found that the result of the force due to gravity plus the tension in the string added up to this resultant force, which is the force centripetal of 2.2 newtons. And so I have this equation: force centripetal is equal to mv squared over r. Well, I know force centripetal is 2.2 newtons. I know the mass is 0.5 kilograms, and I know that the radius, conveniently enough, is 0.5 meters. So if I sort of plug that in, 2.2 newtons equals 0.5 kilograms times v squared over 0.5 meters. Well, the 0.5s are going to cancel. Oh, let's talk about units here. As long as we're here and we have a little bit of time, let's talk about units. This is 2.2. A newton is going to be a kilogram meter per second squared, because it's kilogram, because it's mass times acceleration. So let me just put that up there. V squared over 0.5 m. Okay, so now that kilogram is going to cancel that kilogram. That 0.5 is going to cancel that 0.5. I'm going to have to slide this over like that. So I'm going to get 2.2 meters squared per second squared is equal to v squared. So my v is going to be the square root of 2.2 meters squared per second squared. So my velocity is going to be 1.48 meters per second. Okay. Well, we're going around in a circle that had a radius of 0.5 meters. So that means that the circumference is 2 pi r. So my circumference is going to be 2 times pi times 0.5 meters. So my circumference is 2 times, find the pi button is right there, times 0.5, 3.14, well I could have done that in my head, 3.14 meters. Because 2 times 0.5 is 1, so you get pi. Okay. So if I'm going 3.14 meters in t seconds, that's got to equal 1.48 meters in 1 second. So if I solve that, I'm going to get t is 3.14 meters divided by 1.48 meters per second, and so I divide that by 1.48 and I get 2.12 seconds. So I get 2.1 seconds. So based off of my force centripetal, I found a velocity, and then I knew that it was going around in a circle. I knew the radius of the circle, and so I figured out a time based off of that of how long it should take to go once around. And if you go back and you watch the very first video and you can time it yourself with your own stopwatch, or you can take my word for it, you'll find that the time to go around once in that video is exactly 2.1 seconds. Okay, so that's the analysis of that motion. Coming up next, what we're going to be doing is we are going to talk about going around. We'll talk about going around a curve in a car.